Hey, it's Mr. Lineski with Composite Figures for 2D figures. A composite figure is basically when we take two shapes or two or more shapes and kind of push them together, or we remove a shape from another shape. Basically, this just involves us using two separate formulas or three separate formulas where we're going to add stuff together or subtract some things together. So anytime you get to a composite figure, I always recommend making a plan first. So for this, we want to find the area of the shaded region. So the shaded region here is just this kind of awkward outside part, and we want to figure out, well, what is that total area? So in order to find that, our total area is going to be the area of a square, so that's sort of our outside shape, minus the area of a circle. So we're essentially finding the area of this whole square, but then we're removing a circle from it. So in this one, we're going to subtract. So we're told that the radius is 5. So a radius can look like this. So the issue here is that we don't really know anything about the square. So area of a square is just when we essentially can say length times width, or we can say side squared. And then area of a circle, I'll just say AC, is equal to pi r squared. So we know the radius. So area of a circle is going to be pi times 5 squared. And so we can kind of simplify that out. So that's going to end up being 25 pi. But the issue is, well, how can we figure out the square? Well, if you remember, we can extend this out and draw a diameter. And now visually, I can also draw a diameter here. And if you notice, that's actually drawing the length and the width of the outside of the square. So like imagine that I kind of push this line up. If I were to knock it up, it would kind of fit up here. So if that's 5 and this is 5, well then the outside has to be 10. Same thing here. If this is 5 and this is 5, because all radii are the same, then this has to be 10 as well. So the area of this square is going to be 10 times 10. And so that's going to equal 100. And so now our plan for this is to take the area of the square, 100, minus the area of the circle, 25 pi. Keep in mind you can multiply that by 3.14 to get it as a decimal. And so when I do that, 100 minus 25 pi, that gives us an answer of 21.5 centimeters squared. Again, units here are centimeters because we're talking about area, centimeters squared. For the next one, we are looking at finding the area. So again, come up with a plan first. Notice we're not removing a shape. This one is now, we added a shape. So we have a rectangle, so I'll say area of a rectangle plus the area of a triangle. So now we just need to figure out the areas of those. So the area of the rectangle is pretty easy. We have 6 inches here and 14 inches here, so those are the dimensions. So the area of the rectangle is going to be 6 times 14, and so that's going to equal 84. So now to figure out the area of this triangle, what we're kind of shown here is that from here to here, which if we extend that line out, that's kind of giving us the base of this triangle. So the base of the triangle here is 10. That's this side right here. And then we're also shown from here to here is 8. And so if I kind of push that side over, that represents the perpendicular height. So the height of that is 8. So the area of the triangle is going to equal 1/2 base times height. That's the formula that we use. So we will say 1/2 times the base is 10 times the height, which is 8. And so that is going to equal 40 inches squared. And so now our plan was to add this and add this. So area of rectangle plus area of triangle, so 84 plus 40, and that's going to equal 124 inches squared, again because we're talking about area. And then for this last one, we are talking about perimeter. So I want to remind you that perimeter is whenever we are going along the outside. So we're going to say this plus this plus this plus this. So notice we are not going to add this. That part does not get added. So we have, what do we have? We have a rectangle, and then we have half of a circle. So we don't have a full circle, we only have half of it. So if this is 8, then this has to be 8 as well. In the circle, I know that the diameter is going to be 5 centimeters. Now, because we're talking perimeter, we really don't need to use the formula sheet with the exception of our circumference of a circle. Now, because we're given the diameter, I'm going to use pi d. So, perimeter, we're just going to add 8 plus 5 plus 8 plus pi d. But pi d is going to give me the whole circle. I don't want the whole circle. We're not doing this whole circle. We're only doing half of that. And so that's what we're going to do. We're going to take this divided by 2. So essentially we're taking the circumference and then just cutting it in half. And so when I add all of this together on my calculator, that is going to give me a perimeter of 28.85 centimeters, not squared because we're just doing perimeter. So we should get that as our answer. Alright, that is it for composite figures for 2D shapes. Thank you for watching. I know it, and now you know it.